Hello, and welcome to another episode of Improve Healthcare, the show that focuses on ideas and insights to improve the healthcare delivery continuum around policies, processes, and patients. I'm your host, Rich Greenhill. For this episode, we will focus on the use of advanced technologies in clinical operations, specifically adoption of machine learning into various care settings, the challenges, as well as some considerations. Today, my special guest is Mr. Edward O'Connor, who has been a software developer and technical architect and owned his own software development firm. He also ascended the executive ranks, holding roles such as Chief Technology Officer and Chief Information Officer with clinical organizations. Currently, he's a technology subject matter expert in the health division of a prominent defense contractor. Edward also happens to be a PhD student at Colorado State University, where his research is focused on human-centered machine learning. Welcome, Ed. It's a pleasure to have you.
Thanks, Rich. So glad to be here. You made me sound a lot better than I actually am, so I appreciate it.
No, you're great, and all of us that know you know that. So it's great to have you today. I wanted to get started by just getting you to give us your thoughts around where do you think we are in healthcare around, well, first let's start with a basic definition of machine learning, AI, deep learning, just so that we kind of set the stage for the discussion.
So you're jumping right into the deep end of the pool there. I like it. And it's a good question because I think a lot of folks haven't really established a baseline definition that's meaningful. We can all look up the book and spout a definition, but it's not terribly meaningful. So I'll address those backwards. AI, which is actually the least meaningful term, artificial intelligence for me, is just an umbrella of any tool that's helping to automate or apply some intelligence or learning to a process. At this point, it's such a big umbrella, it's almost a meaningless umbrella. And then let's contrast that with machine learning. Machine learning now we're in the tool level. And we could probably have a half-hour argument as to, is machine learning really AI? How I would define machine learning and how it typically is I often have to explain it to programmers. And so I'll explain and say, hey, we're going to use a model to process a whole bunch of data. Maybe we're going to sort that data. Maybe we're going to look for patterns in that data. Maybe we're going to look at that data and make a recommendation. And they look back at me and say, well, wait, I can just write a big long if check or a case statement to process data. What's the difference? And that's where you really understand what is machine learning, but what's the difference between that and a software program? The difference is in machine learning, we use data to create the rules. In a software program, a programmer actually interviews people, elicits requirements, and codes the rules. Okay. And that's how you know when to use machine learning. If you've got a case where, look, we can't gather together all the right people to gather those requirements, and we can never write that much code. It's too much. So the process we're looking at, it's ineffable, it's too large, too complicated. So instead of writing the code, we have the machine look at the data, and it effectively writes the code. And that code, that's the model.
Thank you, Ed. That's good. And, it's interesting because, these days you hear a lot about all the magical things that AI and machine learning can do, like it's some new technology. And those of us that have tinkered with it, know that it's been around since the 1950s. It's not a new thing. It's, all probabilistic type methods and those kinds of things. Now, how do you think machine learning, what's your take on machine learning and its applicability in clinical workflow? We do see out in the literature that there are a lot of organizations, physicians primarily, that are using these algorithms to do things in precision medicine and other areas. But in terms of patients moving through the system, are there any valid uses that are non-hype uses, I guess, around AI for those types of things?
There are, and I'm glad you phrased it that way, because I think when people talk about machine learning or AI in healthcare, they're really conflating a bunch of different things. They're conflating, okay, how are we going to do research and cure cancer? They're conflating, how are we going to find fraud, waste, and abuse at CMS? And they're conflating, how do we actually move people through the delivery system? So kind of ClinOps, research, payer. These are, three buckets of very different use cases. And as you know, I tend to have more expertise in not the research bucket, but more on the payer side or the clinical delivery side. And one of the problems we run into out there is that people are figuring out a lot of interesting techniques in the research field, and they're trying to shift them over into operational healthcare, and it's not working. And that's because the rules are different. So let me circle back to your question. Are there some real world use cases? For sure. Like, for example, one of the ones I've done a lot of work on is figuring out the actual coordination of patients in a large delivery system, whether it be an MCO, ACO type environment or some sort of virtual delivery system. So if you've got a room of 100 people whose job it is to answer the phone and get patients where they're supposed to get to, or make phone calls and get patients where they're supposed to get to, as you know, that room is always kind of a triage exercise. They're not going to call everybody. They're not going to hear from everybody. Well, how do they decide who to call first? Mm-hmm. And how do they decide where to guide that person? This is a prime use case for machine learning, meaning figuring out every day who's that prioritized list of who we got to reach out to, what's best for the system, and then what's the most likely place where we should route them. And that's where machine learning often drifts into decision support, where you're making those recommendations to those call center folks, those care coordinators. They could be called patient navigators or nurse navigators. The terms change, but the activity is the same. So that's a current use case where we're heavily focused right now.
Okay, that's great. And as you were talking, I was thinking about some of the algorithms that I know how to program in, and thinking about the skill sets that it takes. And as my former time as an executive, I was clueless. I would ask the IT folks or the technology folks, hey, can you work on this for me? Can you create a solution? And now I understand, from having worked with some of these tools, there's a lot of risk related to bias of the models. How do you apply a algorithm that you've trained on a set of data to the real world? Because those are two different things, right? And so my next question is really around, what are the skills that you think executives, mid-level managers, or just frontline folks need to know? I mean, we might have a need around quality, safety, patient safety, and we may say, hey, we need a tool to do X. But what are the risks, and what skills do we need to know in order to make the right decision about what to ask you to do? I don't know if that makes sense.
It does. Yeah, that's a great question. There's a few questions in there. So let's go back to the beginning. One is, what's everybody have to know? What's the baseline knowledge? And one of the challenges in machine learning or AI or, agent-based modeling or simulation, all these areas, is there's a pretty large number of skills that people need to get a basic aptitude for in order to just work successfully as a team. You've got to have a basic understanding of statistics and probability. You've got to have a basic understanding of data quality and lineage and transparency and compliance. You've got to understand just enough of the technology, even if you don't have to do the coding, of just how hard it is to do data wrangling or how you might be able to do reinforcement. And then you also have to have some exposure to ethics and performance testing if you ever want to actually get your models out into the wild where they're giving recommendations in real time or near real time. And so that pile of skills, unfortunately, everybody on the team needs to have a little bit of that expertise. Then, obviously your programmers, your data scientists that are in the weeds, they need a lot more depth in some of those areas. But your management really needs to understand use case applicability. They need to understand, when is machine learning the wrong hammer for a particular use case now? When is it going to actually work? And keep in mind, a lot of the execution staff, often myself included, we don't necessarily know that until we're halfway through. And so, when the programmer gets tossed a problem, the first instinct is, well, let's solve it. Our first instinct isn't to say, well, could we just do this with regular linear regression? Could we just do this with a report? Are you trying to get machine learning to magically solve a problem because you just failed to solve it with a more basic analytical tool? Or is it actually something where machine learning will make this easier? And oftentimes what I see is, look, if you fail to do this as a basic report or a control chart, machine learning is not going to make it easier. So I always push people back to the basics. Make sure you've tried to solve a problem with the simplest technology that you have at your disposal before you shift to the most advanced technology you have at your disposal.
That's a great point. It almost sounds, and there's some research I recently completed on this, looking at competencies for healthcare executives. And one of the things that my team and I noted in the research was that you need almost a clearinghouse. You need an intermediary group. It's one thing to have folks on your team that are physicians, nurses, administrators. That's great. But you need someone, maybe if the C-suite doesn't necessarily want to learn all the deep skills, they need a clearinghouse to really vet these ideas. Someone who maybe has a foot in medicine and in technology. For example, you have medical information officers. They're kind of an example of that. But it's almost like you need a whole group of those folks for advanced technologies, because who can translate what they said from technology to the folks that are making the decisions. How do you think? How do we start? We're probably in a situation now, and I'm saying this from my own experience in the C-suite and in leadership. We don't really know what we don't know. A consultant walks in with a sexy device or a sexy algorithm and says, look, it can predict readmissions. And we're like, yeah, I want that. Without realizing that all the things you just said that you have to know around ethics and bias and stuff. So how do we get to the point where people realize what they don't know? I mean, because right now we're in this thing where people think they know and perhaps they don't know.
Yeah, well, I think what's really critical is for people to go back to basics. So, the conversation we just had, what if I ripped out the word machine learning or artificial intelligence and I substituted enterprise resource planning or data warehousing and data mining? Like, experienced executives shouldn't be falling for this because we've been there before. 20 years ago, 90% of ERP projects were failing. 10 years ago, 90% of data warehouse projects were failing. Right now, 90% of machine learning projects are failing. And the reason why is the same. We're not working backwards from real world problems. We're not. And this is where I'll get on my human-centered pitch here is we have to start with actual humans in the field. We have to identify what are the problems, what are we trying to solve, and we have to work backwards from that. And we really need to just not make the same mistakes we make with every other advanced technology. And that is, we need to stop trying to big bang build a big system that solves every problem. So that we got to work through one use case at a time. We've got to have a realistic balanced team with all the disciplines baked into it, instead of going out there and looking for what is now jokingly called the machine learning unicorn, somebody who just knows it all. I know advanced algorithms and I have a PhD in math and I can code and I understand ethics and I understand law. If you try to build a team around a unicorn, you're just not going to have a team. We just have to apply measurements that ensure ongoing value. Because that's where a lot of the machine learning projects are dying, is they get through the R&D phase. They do a couple proof of concepts. But then people do the math on, can we sustain this? And they realize, this is more expensive than the old way we used to do it. And they've got to start over. So a lot of projects are dying as they try to pivot from R&D into operational value. And again, none of those are new mistakes. Those are classic errors that we've been making in technical project manager, since the beginning. And so it's, again, I appreciate the excitement and I'm excited to apply these technologies to new use cases. I think we're going to change the world. But we have to be realistic and we have to remember all the mistakes we've made on prior generations of advanced technologies.
That's a great point. I'm thinking about, the data mining and just all the steps that you have to go through for ETLs, extract, transforming, and loading, or whatever they do, transfer, whatever it's called these days. But, we think, I believe we think in healthcare that we have all this data. We have big data. We have data from sensors, the Internet of Things, right? And somehow we're being sold in a lot of places that this is, we can take all this big data and do something with it now without realizing, first you have to make sure data quality is probably the most important thing. Is it too expensive to clean this data up? And do we start over, right? I mean, there's all these things. And so What do you think are the risk of pulling a support vector machine or a priori algorithm and saying we're going to apply this to what we're doing to try to find some patterns? What do you think the risks are to doing that? Are there risks?
Yeah, there's a ton. And this actually alludes back to part of a question you had earlier in terms of these machine learning projects tend to work bottom up. We grab a data set, we spend a tremendous amount of time on cleaning that up and wrangling it. I'll also just do a little segue. A lot of folks will say that like that's just a fact. You're going to spend 80% of your time in a machine learning project on data cleanup. I will challenge that. So that's not a feature. That's not a requirement. That's a bug. That means you're doing it wrong. The reality is we get obsessed with cleaning up the data up front, and we get stuck there, and the data scientists get stuck there. And one of the reasons they get stuck there is they typically don't have all the domain knowledge on their team to actually make those decisions. So they play with the data until it tells them what they want. That's a bad habit.
Yeah, totally.
And then in operational and clinical workflow, if you're trying to improve that, one of your big issues is that historical data, it generally illustrates, well, not generally, it 100% illustrates the current process. So the most common reason we're doing machine learning in clinical ops is we're trying to improve process. I don't really need a model that tells me to do things the way I've always done them. I need a model that tells me to do things a better way. So all bottom-up machine learning has a higher risk in clinical ops use cases than normal, which is why I encourage people to think upside down. Think about reinforcement out of the get-go as opposed to just normal data scientist-driven supervised or unsupervised models. What I mean by reinforcement is don't try to clean the data so much. Spend a little time on it, but then try to get it to where you're telling end users, nurses, care coordinators, doctors, hey, this is what I think you should do. And gather feedback from end users where they can just tell you like, no, that's crazy. And keep in mind, you can do this passively, meaning you don't literally have to stick something into their interface. And certainly they don't need something else integrated in the EHR. They're overloaded enough. You can do this passively where you push recommendations into a shadow system and you watch what end users actually do and you can compare the two. So for example, if I think that care coordinator should make a pain management appointment for patient X, and I see they don't do that, they make a completely different kind of appointment. Well, that's a delta between that's fundamentally residual analysis, is I'm analyzing the delta between what actually happened and what I recommended on the back end. Mm-hmm. And I can use that for reinforcement. I can use it for quality analysis. I can figure out, again, is that a bug or a feature? Meaning, did they do the right thing or was my recommendation the right thing? But these projects work a lot better if we rush to market in a sense where we're very quickly comparing real world, what do users, what do caregivers, what's the care team do against what we're recommending. Even if we do it in the shadows passively, we don't have to stick it in their face to gather a lot of data. That works really well. And that's how you can actually improve a process. That also addresses one of your concerns earlier, which is data scientists, myself included, sometimes we get super focused on theoretical model accuracy, meaning, and we compete in competitions over it, Kaggle competitions and the like. We're so focused on accuracy, but we generally don't create performance indicators for, well, how often were the recommendations on this model used by end users? That's my favorite key performance indicator. How unbiased is this? Did we treat a subset of our patient population unfairly? And we get and how accurate is it from that kind of real world residual analysis, comparing what a care team does versus what we recommended? Real accuracy, not theoretical model accuracy, meaning comparing my training set, my control set versus what's left over. So we get really wrapped around the axle because it's fun on kind of theoretical accuracy. But that's in clinical ops, that's maybe the least relevant metric long term. So that's what I encourage people. Don't get stuck with that. Don't get stuck with data wrangling. Don't get stuck with theoretical accuracy. get your model deployed and start gathering end user feedback. That's probably a key lesson for human-centered anything, is start getting real-world operator feedback as quickly as you can, and assume you have no value until you start doing that.
Yeah, starting with the human is quite a it's something that we do in a lot of processes, including process improvement and lean and Six Sigma areas that I've worked in. Interesting that the point you made about that models look backwards, with the exception of like your unsupervised where they're looking for patterns, right? That's sort of a different road a little bit. But, as powerful and as hyped as some of these tools are, they could make things worse. I mean, we already see bias with certain ethnic groups and other marginalized groups. And so it could make things worse if you have an executive or clinical leader who doesn't understand that these models have bias in them. And, I in the research that we did, the paper that we wrote that'll be out later this year, we talked about what happened with, I'm not going to get into politics at all, but you see how the big IT firms, that's what I'll call them, allowed users to comment on things, and they took the users' input, and that drove the algorithm. It wasn't facts. And so what it did is it created a whole new universe of reality for some people, different groups, and thinking about that in a healthcare setting where you have, let's say you have a group of folks who are really healthy and your algorithms latch onto that. And that's the basis of how you build, your operations for that algorithm. And now you're leaving a whole group of people out and potentially harming them by using, subjecting them to things that don't really work for them. So what would you say then to the executive leader, the CEO, the COO, the chief medical officer, vice president of strategy, who's trying to figure out a plan for advanced predictive analytics or decision support or machine learning modeling or simulation? What would you say to them about getting started? I mean, where do you start?
Well, unfortunately, you start the same place you're always supposed to start. You start with, okay, what are our mission, vision, values? What are our goals this year? Where are we trying to move the needle? And you work backwards from that as much as you can without any bias. So it's the fundamental mistake is someone has decided on a tool before they've even selected their problem. They haven't decided they're going to, hammer two boards together, but they've decided they're going to use a hammer. They've picked that tool. And the problem with that is this is a very expensive tool set. It's hard to train for. It's hard to hire for. It's a high failure rate in the industry. So it's higher stakes. And that's true for all advanced technology projects where, it's a higher stakes decision to just decide, we're going to use that hammer. It's the machine learning hammer. But I just encourage everybody to go back to the beginning, figure out what problem you're trying to solve. Try to bring in some honest brokers that can help you navigate and figure out what's the simplest approach, what's the simplest tool, and then try to get some wins under your belt, meaning carve off just one problem that you think, no, machine learning is the right hammer for that. Carve off and get yourself a win. The other thing I encourage people to do is start with governance, meaning especially in clinical delivery and operational healthcare, start with your operators, start with the care team. So be patient-centered. The care team is supposed to be the center of this. The patient's supposed to be the center of that care team. Start there and think about governance. A better way to phrase that would be think real hard about when your smart machine generates a recommendation and the nurse says, tell me how you arrived at that. Make sure you saw that problem up front. So think about explainability assets, think about charts or graphs or visualizations. They're going to tell that nurse, this is exactly how I came to that answer. That would also imply be really cautious about starting with deep learning models or highly complex models for your first year or two of projects, because they're going to tend to fail at the explainability step. Not saying you can't figure that out. There are ways to make those models explainable, either with surrogate models or with things like Shapley or Lime. There are different techniques and visualizations, but start with things that are easier to explain. And then once you build some trust, with your doctors, your nurses, your operators, then you can go a little wild with it. But just keep in mind what they've been through in the last decade with health IT. We hit them with EHR systems that took 7 to 10 years, and for some folks, we still aren't there with reestablishing trust. Don't make machine learning and decision support, recommendations, or these models the next EHR, where we're going to lose all credibility for a decade. And honestly, just slow these folks down to where we're the next system they're going to ignore, and we have to recover and regain their trust.
That's really a great point about the deep learning models, because, as I've programmed with some of them, they are very, there are ways, like you said, to look at them, but that opens the door to risk, and if a algorithm makes a decision and the physician or the care team decides to follow that decision, where do the chips fall with torts, and who do you blame, right? And so there's a lot wrapped up in what you said. That's very good. So as we get ready to close here, is there something you wish the rest of us would do or think about to make the life of folks like yourself, technology leaders, executives, folks that are trying to build these models and be forward thinking and thought leaders? Is there something you think we could do, or is there something I should be doing as someone now who's an educator who has health administration knowledge as well as these advanced statistical tool knowledge? What do you think? Some wise nuggets that you'd leave us with?
Yeah, I think the key area I encourage people is don't be afraid to question everything. Meaning, if someone comes in and offers you something that seems too good to be true with an advanced technology, your first step should be to test them to see if they can explain it to you in a way that you understand and in a way that your staff will trust. And if they can't do that, move on. Now, I'm not saying if they can't do that, they're bad at this. I'm just saying operationally, you'll eventually fail if your entire team can't explain what they're doing, why it matters, why they should be trusted. And keeping in mind, I think the clinical operator audience is one of the toughest. That's their licensure. They can't just say, well, I'm just following orders on that. I'm just doing what the administrator told me to do. It's their license. It's personal. Right. And, that's one thing I love about working in healthcare. There's a deeply personal relationship that people have to deliver high quality care to the patient. Folks in healthcare care. They truly do. Well, that's the big benefit. That's great for working with those people, but that's also why you need to make sure everyone on your team, every technologist, every executive, they understand what they're doing, why, they can explain it in plain language, they can justify it in a way that someone will take action on their recommendation. But as soon as you have even one person that isn't doing that and says, no, trust me, don't worry, this is too hard for you to understand, just trust the model. Just one of those people will break an entire initiative. So that's my advice. Don't believe anything. Make people whiteboard it and explain it until you understand it. And if you can't get to a joint understanding, don't move forward with the project.
That's great advice. Well, that probably nixes a lot of things. Explainability, as you said, is very important. This has been a really informative discussion, Ed, and I certainly want to thank you for your time and expertise. In technology, is here to stay, and there are a lot of things that healthcare leaders, educators, and our technology leaders, there's a lot for all of us to really consider and think about as we continue to go down this road. So I want to thank our listeners for listening, and be sure to visit and subscribe at www.richardggreenhill.com for upcoming topics and speakers. So thank you, Ed, and it's great to have you.
Thanks so much, Rich. Really enjoyed the talk.
Appreciate it. Have a great day, everyone. Thanks for listening.